I've had my Starlink Generation 2 kit for about 6 weeks now, and I've been using it for my primary internet connection at home ever since. Generation 2 is the one that's a rectangular dish. I have no experience with Generation 1, which is a round dish. So this is all focused on the rectangular dish and the router that comes along with that. The default kit contains the dish, a 75-foot cable, and a router. If you need a longer cable, Starlink actually also offers a 150-foot cable if you want that. And one important thing to note is that the Generation 2 router does not have an Ethernet port. So if you want to connect an Ethernet device with an Ethernet cable to Starlink, then you will have to purchase the Ethernet adapter. It's only $20 and it's also available on the starlink.com site and the shop. But remember that when you get a notification that you can purchase the kit, that you, if you want it, also get the Ethernet adapter with it. Otherwise, there might be a long wait time or a long delay to get the Ethernet adapter. One thing is that the Ethernet adapter, from a physical connection point of view, connects in between the dish and the router. So you have the long cable that goes from the dish to the router. You unplug it on the router side. You plug that connection into one side of the Ethernet adapter, and then the other side of the Ethernet adapter has a short cable like a foot long, and you plug that into the router. And so the Ethernet port itself sort of situates itself in between the dish and the router. But that's neither here nor there. So from a networking point of view, which is really what this video wants to address, by default, if you don't have the Ethernet adapter, or even if you do, the default setup of the router is Wi-Fi mode. And so it supports both 2.4 and 5 gigahertz. And that's actually quite useful because many IoT devices, such as a remote power outlet or a thermostat or a door lock that's on the network, those devices typically require a 2.4 gigahertz Wi-Fi network. And many new routers are 5 gigahertz only. So it's actually quite nice that Starlink out of the box supports still the old 2.4 and also the newer, more widely used, but newer 5 gigahertz. The default setup means that the router runs its own DHCP server for the internal network. So any device that you connect to the Wi-Fi network on the router will automatically get an IP address assigned from the router. You cannot disable this, it'll just always do that. Also, only support for DHCP is there today, so you cannot say, oh, I have a specific device and you have the MAC address of that device and you want to allocate a static IP, even from within the network, for your internal network. You cannot, the router software does not currently support assigning static internal IP addresses to specific MAC addresses. I have not tried this, but my expectation is that it would work, that you assign a static IP address internally on your, let's say, laptop or server, and that should probably work just fine as long as it falls within the same network and uses the same subnet mask. In terms of IP range, the router's internal private network is based on 192.168.1.x. with a 255.255.255.0 net mask, and that's also not configurable. I assume that in the future this might be, but currently it's a specific IP range that's not changeable. So the DHCP server will assign IP addresses within that range to devices that connect to the Wi-Fi. The dish itself has an IP address as well for configuration and monitoring, and that listens on 192.168.100.1. So it's outside of the network of the router. Now, if you use the router in the default mode, then any device you connect to the Wi-Fi network will be able to directly connect to 192.168.100.1 because the router will do the right thing. The connection to 100.1 will be going to the outside network, so to speak, and come back in. So it's not a problem. You don't need to do anything. On the Wi-Fi side, you have the option to just use 2.4 and 5 gigahertz together and just have one SSID with a password. Or if you prefer to split it up and have two separate SSIDs with a password, that's also possible. You just have to click on split or not. sometimes it's useful to do the split because it allows you to know which SSID is for 2.4 gigahertz and which is for 5 gigahertz. So when you're setting up an IoT and it displays a list of different networks to connect to Wi-Fi networks, then you know which one to pick for the 2.4 gigahertz. If you add the Ethernet adapter and you maintain the default mode, which is Wi-Fi enabled, then when you add the adapter and you plug a device into the Ethernet port on the adapter, it will also get a DHCP address assigned within that same range, so 192.168.1.x. And so any device that's connected to the Ethernet adapter will be able to communicate with any device that's connected over Wi-Fi and vice versa. So it'll be on the same network behind the router, and they can of course all talk to the outside world, and both Ethernet and Wi-Fi can talk to Dishy on 192.168.100.1. The Starlink router also catches dishy.starlink.com, or in fact there's a DNS entry for dishy.starlink.com that actually points to 192.168.100.1 as well. So if you type that in your browser, then you will get to the configuration site on the dish, whether you use your phone app, which does the same thing, or you can use your browser, and you basically have a similar interface as well. The reason I point this one out is because there are some tools you can run where you can get statistics out of the dish, and it's useful to get those statistics and keep them. As of January 22, it's now also possible to disable the Starlink Wi-Fi router. There's a feature in the phone app that's called Bypass Starlink Wi-Fi Router. And when you click on that, it will disable the Wi-Fi, and the Ethernet port is the only way to have network communication out of Starlink. And it's also required to have the Ethernet adapter installed in order to be able to set this feature, of course. When you disable Wi-Fi, the router still will be powered on because the router actually also provides power through the cable to the dish to work. So it's not like it's possible to just disconnect the router and when you use this option. The router will still run, but it won't provide any networking or Wi-Fi offering options to the house or to the location. So when you do this, the setup basically turns into bridge mode, and the device that you plug into the Ethernet port will get the public assigned public IPv4 address directly. So in my case, when I have my Ubiquiti UDM Pro, it will show the 100 something IP address that the dish had, and so the external IP address that was assigned, instead of having a private IP on 192.168. So the advantage here is that you remove the double NAT, because what that means is you have Starlink with the router that has a private NAT network, then you plug your router or gateway into that one, and it also does its own private network and NATs itself behind it, so that's double NAT. And by putting the router in bypass mode, you basically remove one level of indirection. Now, somebody asked me before whether that had a performance impact or not, and as far as I can tell, the speeds are not high enough for this to really have a performance impact. But the more important part is that it allows you to disable the wireless modem, and so you remove interference if you already have a Wi-Fi network set up, which is the case for me. The other thing is that if you want to re-enable Wi-Fi, then you'll have to do a reset of the router. But per the website, it's basically unplugging and plugging in the modem 3 times for 2 seconds, and then it will automatically reset. And there's very little state save, so it's not like it takes a long time to get back to the original mode. So from my point of view, and my preference is that if you already have your own home network set up with your own router or gateway, then this mode is ideal, because all you do is you set you get the Starlink kit, you get the Ethernet adapter, you configure it in bypass mode, you take an Ethernet cable from your gateway, plug it into the Ethernet adapter on the Starlink side, and you're done. And it will act just like any normal external modem for internet connectivity. And it removes that double NAT, but like I said, it doesn't really show much of a difference. Now, one thing to keep in mind, of course, is that if you do this, then by default, you disable access to DISHI. So 192.168.100.1 will be outside of your gateway, and you will have to create a static route on your network that will basically say route any traffic to this IP address to the WAN port. It's really easy to do. For the most part, most setups will make it really easy, but you do have to do it. Otherwise, you will not be able to talk to the dish, and the phone app, when it's on your home network, will also not be able to find it. But once you set a static route, that's not a problem. Also, as of January of 22, right now it's not possible to get a static public IP address from Starlink. This might happen in the future, but right now it's not. It's a dynamic public IP address that's assigned. It's also not possible to have inbound TCP connections or UDP connections. So basically, the way it's configured today is that Starlink works very similar to, let's say, T-Mobile 5G or something similar, a carrier-grade internet connection. And so they use carrier-grade NAT. And so even though you have a public IP address, it's still behind another public IP, and there is no way from a system outside of your network to actually get routed to the IP address that was assigned to your gateway in Starlink. So outbound in is not possible, but of course inbound out is not a problem. Now, with outbound in not being possible, that means that you cannot set up a VPN on your home machine and VPN in from the outside, because you need a publicly accessible IP address. You can do VPN out just fine, so that's not an issue. The other thing that's not mentioned in the Starlink FAQ is voice over IP support. And as far as I know, you will need inbound support as well for voice over IP to work, because otherwise you cannot receive any inbound phone calls. And one example of that is Ubiquiti Talk voice over IP. So if you do not have a public IP on your gateway that one can connect to from the outside world, then Ubiquiti Talk will not work. So it will not work on Starlink in this case. It's currently also only IPv4 support. It might be supporting IPv6 in the future, Starlink, but that's unknown. I don't have access to the roadmap either. And then lastly, keep in mind that when you disable the router and use bridge mode, it removes local NAT. However, Starlink operates as in CGNAT. So there is still some level of network address translation happening, but that's outside of your control, so to speak, on that side. I have a few screenshots of the app, and this just shows on the left side, it shows bypass Starlink Wi-Fi router option. So when you click on that and you hit save, then basically it shuts down the Wi-Fi on the device. And from then on, the only way you do configuration is by doing a reset. There's also network statistics available on the app. So when you click on the statistics button in the app, then it'll show you uptime, it shows the latency and usage. So latency is useful. I've always seen somewhere between 20 and 35 milliseconds as a normal range. I've seen 19 milliseconds once, and sometimes it goes higher, but it's been pretty consistent in the mid 20s to low 30s, which is very comparable with DSL connections. And then on the right side, this is when you do split 2.4 and 5 gigahertz networks, then it lets you configure at the top the 2.4 gigahertz network, and then below that the 5 gigahertz network, so you can split it up if you want to. Performance. So, people run speed tests, and of course there's different performance at different times of day, just like any other network. But I've seen typical speeds in the San Francisco Bay Area from around 200 to 240 megabit down and about 25 to 30 megabit up. And the latency being, like I said earlier, mid-20s to mid or low 30s from a latency point of view. Again, similar to DSL. One thing I want to point out is that I've used Starlink during really bad weather. We had a atmospheric river a few weeks ago here, and it was days of very heavy rain and very thick clouds, and I had no downtime, and my network connection stayed up just fine. I've also not seen any difference in running in bridge mode or regular Wi-Fi mode. The performance seems to be pretty similar, but again, as I said before, the double net is not going to affect performance very much at speeds of 200 megabit or 25 to 30 megabit up. The good thing with low latency, of course, is that it makes Starlink very useful for interactive sessions. I do a lot of SSH to a remote server, and the current latency is low enough that I can just type interactive, and I don't have to wait long for the echo of the characters that I type to come back. So it makes remote logins quite usable and zero problem. I've done many Zoom sessions and multiple Zoom sessions in parallel, along with playing music or having downloads happening or uploads happening, and it works pretty well. I haven't seen any any specific issues that would not be normal for an internet connection. Starlink has no bandwidth cap right now, so you can download a terabyte in a month and it just keeps going. There's no limit to it. But more importantly, it does not throttle downloads. What I've seen in the past with internet providers is that when you'll download a very large file, let's say a 10 gigabyte file, that it will work really fast for the first 500 or meg or 1 gigabyte, and then it starts to drop. So you might get, let's say, 100 megabit, and then after 1 gigabyte of download, that drops from 100 to 20. And many providers do this, and certainly seen this with cable providers. The reason the first part is fast, my understanding is that it helps with speed tests and make them look good, because speed tests try large downloads and then measure how long that takes. And so then afterwards it sort of drops off. Starlink does not do that. So if you download a huge file, then the performance of the download or upload will remain fully consistent throughout the entire download or upload. I've also done a lot of tests doing mixed workloads where I'm doing uploads, I'm doing downloads in parallel from many clients, up to at least 100 clients on the network that are doing some form of upload or download in parallel, including cameras and file downloads and backups and all that stuff. And these mixed workloads have been perfectly fine. There's been no issues whatsoever. Monitoring. So this is what I meant with having an interest in Dishy and that IP address 100.1 and then port 9200 in particular, you can use to make gRPC calls. Now I have a link here to a GitHub project, which is not mine. I cannot take credit for this in any way, but I used this software that was published, the source for it's Python code for the gRPC tools. And when you download that on your Linux box or your Mac or so, you have some command line tools that let you pull down statistics and then put them in a time series database and use something like Grafana to keep track of the history of this stuff. So I have a small Grafana database or a InfluxDB database with Grafana fronting it for my electricity setup and my power pack and solar panels. But I use the same setup for collecting data for Starlink and as well. So that works. That works just fine. Given that I'm off-grid electrically, this was actually quite relevant to me. Starlink obviously is a very good off-grid solution because you don't need any connection to the street. Typically cable and DSL are coming along with the electricity lines, whether it's the overhang lines, the poles on the street, or whether it's underground. And so if you're in an area where you do not have that, then your only option has always been mobile internet or the old satellite internet, which has massive bandwidth caps and very low bandwidth and very high latency. And so Starlink basically offers you a better than DSL speeds, typically DSL type experience in terms of latency, and it's all straight to the satellite. So in case of a disaster, if there's a major power outage, for instance, if we were to end up with an earthquake here in the Bay Area, there might be a massive power outage. And so if that's the case, then the mobile internet might be down, or your cable provider might have no power for its connectivity. And of course, a satellite will keep happily keep spinning up in space and will work just fine. So in that case, if you have electricity at your property, then a Starlink solution will give you your internet connection, which you can use for phone calls as well, right? So it's definitely very useful. One thing to point out here is that right now the Starlink satellites do need a ground station. So when you communicate with the satellite, it'll go down to a ground station and then continue on the internet. However, my understanding is that with the new Starlink satellites being launched since late 21 and now in early 22 and onward, these satellites have the ability to communicate with each other in space using lasers. And so then if a ground station were to be down, one satellite can communicate with another one and then go down. So the redundancy in that aspect will only get better as time goes by as well. So it'll make this an even better solution in the future. So I have two different home setups that I tried. So in the first few weeks when I was not able to do the bypass setting, it was not a problem. I had the Ethernet adapter. I have my UDM Pro, and that is my gateway. It has a bunch of Ethernet switches behind it, and all my house networking is on it with access points, with internet cameras, with storage, with my laptops and desktops, all the IoT devices. And so they're all behind this UDM Pro and its set of switches. And so all I did was plug the WAN 1 port of the UDM into the Ethernet port on the Ethernet adapter of Starlink. And even though it was with the Wi-Fi enabled and the NAT enabled, it worked just fine. The UDM Pro got a 192.168.1.100 or something address assigned, and so it was NATed, but it doesn't really care. It does its own thing behind the UDM gateway, so it all works just fine. And the Dishy was also available from the outside because the .100 network was outside the range of the gateway itself, so it'll go out of the WAN network and work just fine. And my home network has its own access points, its own SSIDs. So the only thing I had to be careful with is making sure I did not configure a SSID with the same name on the Starlink Wi-Fi router as on my home network's access points. And of course, I did notice some interference, so I moved my Starlink router out of the way. In fact, it was outside in a watertight box so that it would not interfere with my home network. So that was important to do. And then the current setup, since the last few days after the bypass mode support was introduced, I just enabled that, and I didn't have to do anything different physically. I just had it rebooted the Starlink router, and my UDM Pro, that's still connected the same way, WAN port 1 to the Ethernet adapter, and it now gets the 100.something or the 90.something IP address that Starlink provides to the modem, and everything just works. So I didn't have to reconfigure anything on the UDM, it just gets the IP and it works. It loses the double net, so there should be a little bit of, I guess, advantage. But more importantly, I don't have the Wi-Fi interference anymore, and so that has helped a little bit. And I did have to create the static route, so I go into the UDM Pro network setup and go to advanced settings, static routes, and very simply add 192.168.100.1, point to WAN 1 for routing, and that was it. So now everything still works. The utilities still work from my Linux server in the house, and my phone app still connects and everything. So that's it for now. So it's quite a bit of networking information. When there are new features and they're interesting from a Starlink usage point of view, then I will create more videos. I hope this info is useful. Thank you for watching.